My name is Paul Turnbull. I'm a Senior Solutions Architect for Red Hat, actually based in Vancouver. On my left here, I have Gerald Nunn. Gerald is one of our Senior Middleware Solutions Architects, and he'll be helping me actually show you some really, really cool stuff in OpenShift. So there'll be audience participation, right, Gerald? Yep, and I think there's some prizes at the end as well, okay? What I wanted to spend, I don't know, the next, I could talk for hours about this, but we'll try and cap it at about 30 minutes or so. I want to talk a little bit about containers. I want to play out a business rationale for platforms, okay? We have a lot of customers who, when they look at containers and deploying applications at scale with containers, they often try and do DIY, right? They'll download Docker, they'll play around with Kubernetes. So I wanted to just share with you some of my experience in talking with customers in Western Canada who've gone through that process, some of the learnings they got from that, and then make a case for looking at a true platform, right? For deploying, not only allowing developers to deploy containerized applications, but also run them in production at scale, okay? And as we go through that conversation, I'll touch on hybrid cloud, mixed hybrid cloud. How do you create agnosticity for those containers and the storage on which they sit across clouds, right? So how do you decouple yourself from those traditional cloud stacks? Talk a little bit about DevOps. I think it's clear from the presentations this morning and this afternoon. I mean, DevOps is a culture, right? It's not just a technology. I'm a technologist, so I'm going to talk to this from a technology standpoint. But I'm just going to talk about how do we narrow the expectation gap between developers and what operations, infrastructure operations teams are able to provide. We'll talk about a little bit about what a container is. I'm sure a lot of you in this room know what a container is, but I'll just provide a level set for that. And I'll also explain to you what it is not, okay? Sometimes people think that containers can solve everything, and that's not necessarily the case. We'll talk about platforms, OpenShift. We've talked a lot about the province of BC, okay? Todd and Shay at the back of the room there. A very, very successful story for OpenShift itself. I'm not going to go into a huge amount of detail there. I'm just going to call out a couple of areas that they wanted to focus on initially for the whole container deployment initiative. These were our core business challenges. Todd's already mentioned some of them in the panel this morning. But more importantly, what were the key results that came out of that process? So did they tick off all of those boxes? Did they solve their operational challenges? So here's an interesting stat, and I actually went back through my notes of all the different organizations I met with in the last 6 months or so, just to try and validate this number. So DevOps means lots of different things to different people, but 78% of the industries that I talk to, and this number's reasonably accurate, are looking at some way to improve performance in how they deploy and run applications, right? And that's everything from I need to make changes more frequently, I need to be less afraid of making those changes in my production environment, and God forbid if something breaks, I need to be able to undo it very, very quickly, okay? This number's gone up quite significantly over the last 3 to 4 years. So the takeaway from that is you guys, if hopefully you're all looking at the DevOps culture, you're not alone, right? There's a lot of organizations that have already taken this journey, BC Gov being one. So it's not something that's on the fringe here. This is mainstream. But from an IT perspective, so when I talk about OpenShift, what is the problem that we're actually trying to address? It's the expectations between the development team, right? So I develop an application, maybe I'm coding on my laptop. I don't really much care about the challenges of creating the infrastructure to support that development activity, okay? I don't really care if it's a virtual machine or if it's a container. I just want an infrastructure that I can leverage to start to do my coding, okay? The challenge today, and we've seen this in a number of areas, and I'm sure the Todd and team would agree with this, is the expectations of the developers, not always the ability of the infrastructure team to deliver, right? So I see everything. I was in Edmonton yesterday. We had some conversations there where some customers were experiencing weeks to months to actually provision infrastructure. So I'm a developer. I need 3 RHEL containers. Within those containers, I need these particular development tools. I need this much storage, this much compute. Could you please provide that to me? And then they sit and wait, okay? And on the back end, that's going through the virtualization team. It's going through security audit. It's going through all the storage provisioning and all the other things that happen. And eventually, it comes back to them, okay? And they can start to do their development. So what we're really trying to do with containers is decouple that, and I'll use this term a lot, right? Is to decouple the process of doing the application development from the actual operating system, right? So most infrastructure ops teams are managing up to the OS, right? They're managing compute, network, storage, operating system, patching of that operating system. As soon as you start to talk about applications, that's another group, right? It's an Oracle database group. It's a PeopleSoft group. It's an SAP group. So what we're trying to do is logically separate those out, that delineation, so the developers can do what they need to do, right? And the infrastructure guys can keep everything else ticking so the developers can be productive. If you think about your infrastructures today, so we've heard mention of mainframes, bare metal servers, hypervisors. If you think about, and I think Chris mentioned lasagna in there as well somewhere, but think about infrastructure as being multiple layers, right? They're fairly complex to keep functioning, performing well, okay? If you need to make any changes to those infrastructures, again, patching, that can be a complicated process, right? We all know what outages are. We all know what change requests are, right? I need to put a formal procedure in place to make that change to make sure that it doesn't disrupt my business, okay? So there's a risk factor involved there. So I talk about agility and acceleration. I'm also about talking the risk posture when we make changes to the environment. And as a result of that, we may have frequent outages to affect those changes, right? So we're not only trying to simplify the relationship between the developer and the infrastructure teams, but also provide benefit back to the business to ensure those services and applications continue to run. So as I mentioned, developers and IT operations have different focus areas, right? The developers just want to code, and the IT operations want to run the core infrastructure. So we talked about that the solution to this problem is really containers, right? And I'll talk in a few slides here around what customers have been doing with containers. But really, in essence, what a container does, and I draw the analogy, my son is 15, soon to be 16 now, but when he was younger, he used to play a lot with Lego, okay? So think of a container as a Lego block. It's kind of a neat analogy, right? If I want to build something, I can put these Lego blocks together, right? So you'll hear me mention things like microservices. Putting Lego blocks together, the Lego block does a specific task, but when you put it with other Lego blocks, it builds something, okay? So containers are neat in the sense that they are stateless. In other words, they can look and behave exactly the same way each time I deploy them. And through automation tools like Ansible, I can ensure that's the case, and it's always the case. They are faster to deploy, so containers tend to be quite a bit smaller than a virtual server, okay? Because what you're doing is you're decoupling the operating system, right, from the bits and bytes that the application needs to function. So I've got lots of examples of customers who've done density studies on, I can fit 12 to 15 VMs on this particular piece of compute. And when they take those applications running inside those VMs and move them to containers, I can now put more containers and different types of containers performing different roles on the same compute platform, okay? So you can go significantly more dense in terms of your container deployments typically than you can with virtual servers. Now that has some ramifications that I'll discuss in a few slides down the road, but they are smaller, which means that you can move them around a lot easier, okay? If you have disaster recovery, business continuous requirements, they're a lot easier to handle than a full-on virtual server might be. Okay, so some other things to think about. I talked about the first one on the left here, the sandbox. So with OpenShift, we pull out the operating system. We provide a common kernel layer. So in this case, it's Red Hat Enterprise Linux or Atomic Host, as I'll talk about in a little while here. And then everything else sits above that as a container, accesses that common layer, okay? They are portable. So how many people in the room here are looking at public cloud stacks? Azure, okay? Amazon, quick show of hands, Google, okay? Containers are portable, okay? I remember being a scruffy, I don't know, 16, 17-year-old back in the UK a long, long time ago, pulling CDs off the front, actually floppy disks, off the front of Byte magazine. If anybody knows what Byte magazine is, right? And it was a Linux disk, and I could compile my own version of Linux, Paul Turnbull's kernel, right? Kind of cool for a hobby. But that ability to recompile a kernel actually slowed down, in our opinion, Red Hat's opinion, it slowed down the adoption of Linux as an enterprise operating system, right? If you remember when Linux first came out in the data center, you had a whole bunch of different flavors of Linux, right? United Linux, and you still have half a dozen different types of Linux. We feel that that slowed down the adoption of that operating system in the data center. We don't want to make that mistake again for containers, okay? So the ability, in order for containers to be portable, they have to have a common format, okay? So Docker is the 300-pound gorilla in this market, okay? There is an organization called the Open Container Initiative, or OCI, you can Google it. And it's the who's who of public cloud providers, so Google, Microsoft, obviously Red Hat's in there, VMware's in there, the who's who. It's a list, a very, very long list. So they're working on defining what that container format needs to look like, okay? So when I talk about OpenShift and I talk about Docker containers, I'm talking about the ability to take a container that could run on your hypervisor and run it the same way in Azure as it does in AWS, as it does in Google, right? So we're decoupling, that term again, I'm decoupling the application from the public cloud stack, okay? Now think about that for a second. So for those of you in the room who are running VMware for VMs, and you want to use Microsoft Azure, okay? So Microsoft Azure runs Hyper-V, okay? So there's a challenge there in portability of that construct, so in this case a virtual server, from on-premise to Hyper-V if you're running a different hypervisor, and from there to another public cloud. Containers completely breaks that model, okay? So now you can move a container around and its contents to different public cloud providers, okay? Make sense? So down the right-hand side here, we talk about, well, I've already mentioned the dependencies, the packages within the container themselves. We can push these containers through CI/CD pipelines, okay? So we all have cell phones, right? We all know how often those applications get refreshed on those cell phones. We've already heard some amazing stats today of hundreds of thousands of deployments and commits being done daily. This is how these organizations are doing it, right? They're automating the CI/CD pipeline so they can go from, for example, somebody posts a commit to GitHub. The platform, so in this case OpenShift, knows that that commit's happened. It picks up the source code. It takes the source code. It compiles it into a container and then runs it through an entire CI/CD pipeline, okay, so including automated testing, right? And can optionally push that out into production. And you can do that end-to-end completely in an automatic fashion and do that many, many times a day, okay? That's the power of this type of technology. So now, really, containers start to decouple. The developers can do what they need to do from a development standpoint, knowing that the operations teams can manage up to the infrastructure, up to the operating system, and the developers can continue to do what they want within their containers and not be impacted by what's happening underneath that infrastructure, okay? So this just talks to my earlier comments. So developer posts some code into, if you start at the left, into the source code repository. GitHub is one of the more common ones, runs it through a CI/CD pipeline, throws it into a container, and deploys it, okay? So I mentioned public-private cloud. You can run these platforms on hypervisors. We'll talk about why you might not want to do that, but you can do it. Public-private clouds as well as bare metal builds, okay? Here's an interesting stat from Docker. So this is year to date. So 900,000 containerized apps on Docker Hub. So if you go to Docker Hub, and I think this was covered a couple of times, we're now starting to see Docker container-based image deployments of applications, right? So Red Hat themselves, we deliver most of our JBoss middleware portfolio as containers. If you want to run them as containers, we have them available as containers versus build it yourself. So 900,000 Docker pulls, Docker Hub application pulls, and 12 billion actual image pulls from the Docker Hub itself. 12 billion, okay? Massive numbers. So here's my next question. So here's the next question. So that's 78% I mentioned on the first slide. That's organizations that are looking at containers for application deployment. However, when we look at customers that have actually successfully deployed container applications into production, that number drops significantly, okay? Somewhere in the region of 35%. In other words, there's lots of companies out there that are looking at containers. I heard several mention they're looking at Docker. As I said, we were in Edmonton yesterday. There's lots of customers looking at Docker there, or they're looking at Kubernetes for orchestration. But they're not able to make that leap to actually deploy them at scale in production, okay? The reason for that is because deploying containers at scale is actually a little bit more complex than it might first appear, okay? So for example, this is a simple example. I got three servers here with some storage on. I'm deploying containers, right? So my first question is, well, where am I going to put this container? Which host is it going to go onto, okay? What if that host doesn't have adequate resources? Where else can it go, okay? How do I monitor the state of those containers? So if a container dies, how do I spin up another one, right? How many people in the room know what elastic infrastructure is? Okay, so if I need extra containers to meet a particular spike in I/O activity, how do I know how to do that? Okay, so all of these questions, yes, they use containers as the construct, but containers in themselves do not provide those types of capabilities, right? Now then, if we take this a stage further, going back to my Lego block building analogy, what if I have services that are made of multiple containers? Right? So I have a container that does authentication. I have another one that does core security. I have another one that takes care of storage. Okay? And I bolt these together, microservices bolt together to create one service. Right? How do I manage those interrelationships? Right? If I want to deploy lots of that type of service on one platform, multi-tenancy, right? How do I ensure that those services remain isolated? Right? So a security discussion. Okay? So again, we're using containers, but containers themselves don't address these requirements. So there's a whole host of things that containers natively just don't do, right? They don't schedule things. They don't take care of lifecycle, right? So I'm pushing a container through test, dev, QA, pre-prod, and production. They don't take care of that, okay? They don't do my elastic scaling. And by elastic scaling, I mean not just scaling out, but scaling back again, okay? And if I don't have enough infrastructure on premise, maybe I punch out to a public cloud temporarily, right? And then when I finish with that, I just dissolve that infrastructure, that kind of stuff. Containers can't do that natively, okay? Persistence. So we had a question yesterday in Edmonton around, well, containers are kind of cool, but what if I've got a database? Okay, so I've got a database that sits somewhere, okay? That's persistent data, right? So if that goes away, my application breaks. Can I run databases inside containers? Yes, you can, okay? If I want to run a SQL database in Microsoft Azure, and I also want to run a SQL database, the same SQL database potentially in AWS, you need that same abstraction layer. So containers abstract the application, okay? Persistent storage, software-defined storage, we've heard that mentioned a number of times, that abstracts the storage layer. So it doesn't matter to the SQL database in that example whether I'm sat on Elastic storage, right, from Amazon, or whether I'm sat on Azure storage. I've decoupled that stack, right? So I've decoupled my persistent data. I've decoupled my application. Now I can move those things around independent of those stacks, okay? The biggest concern I get around public cloud when I talk to customers about it is the fear of lock-in, right? I don't want to be locked into those stacks. I want to have that flexibility to be able to move things around. And we have numerous examples of customers using these types of technologies in the banking sector, okay? So there's banks on the east coast of Canada that use this type of technology to literally play off one public cloud provider against another. right? So they're hosting, and they're doing this at scale, right? Tens of thousands of containers. But they will literally look at the cost model for Google, the start of the month, and if that's the lowest cost model out of their public cloud providers, that's where their containers sit. 4 weeks later, they'll go back, check the costing model. Google's not the cheapest anymore. It's now Azure. And they literally can move. Actually, they don't move. They're stateless. They recreate the 10,000 containers in Azure, and then they destroy the ones in Google. Okay? It's a really powerful message that the way the banks are using this technology. So container solutions themselves, we talked a little bit about the host. So in the case of OpenShift, we're running on top of Red Hat Enterprise Linux. Okay, you always need a platform. So basically, all of those components we just talked about, the scheduling, the monitoring, the security, the multi-tenancy, the access control, that's handled by the platform. It's using containers to facilitate the deployment. That's the sort of magic glue, if you will. On the management side, I think, Chris, may have touched on this slightly. So for customers who want a multi-tenant deployment of this technology, or they have multiple business units and they want to provide self-service access to the application development platform itself, you can do that through a management portal. So you can customize those portals. And for a developer, it could be something as simple as I need 3 of these, I need 2 virtual CPUs per container, and I need 5 of these, and I need 200 gigs of storage for each container, right? That kind of stuff. So it's click, 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 submit, and then literally a few minutes later, the developer's ready to go. Okay, so self-service. And then, of course, the storage discussion we just had. In a lot of cases, customers that are deploying containerized apps are going after greenfield, and they're going after stateless, okay? But that doesn't mean you can't go after brownfield. You know, the Innovation Lab is a great example of that, right? And you can't go after applications that have databases. It's just most customers are going after that greenfield stuff initially. So yeah, so on the host side, Enterprise Linux is the standard kernel. So this is certified in all the public cloud providers. Okay, so you can deploy OpenShift and containers on top of full Red Hat Enterprise Linux. Or if you want a stripped down, a tuned kernel, we have something called Atomic Host. So this is specifically designed to just run containers at great speed. Okay, so it's got all the other peripheral stuff flipped out. Thank you. OpenShift is the platform. Okay, we've talked about that a little bit. CloudForms is the multi-tenancy cloud management platform that you can optionally use to provide access through to OpenShift. Okay. So think of, I'm thinking the BC Gov example, you may have different ministries accessing the same OpenShift infrastructure, but through that CloudForms portal. So it looks and behaves differently, it's secure for each organization, and you can do things like audit trails and compliance and monitoring of who's gaining access to which environments and the types of requests they're going through, right? You could even go as far as if a particular end user requires infrastructure, that has to go through a workflow for approval. So who does it need to go to get final approval before CloudForms goes off to OpenShift and actually asks OpenShift to do something, okay? Storage is Red Hat Storage. Again, if anybody wants to talk about that, we can talk about that, but essentially it's software defined. So this is commodity compute, internal drives, horizontally scalable, vertically scalable, very, very cost effective. Okay, so these are the types of technologies that, you know, the likes of Google, if you go to Google and Google a Google data center, that's a mouthful. This is how they do it, right? They're not buying off-the-shelf servers. They're buying commodity white box servers, thousands and thousands of them, and putting some really smart software on top of it to create volumes of data that can scale and be very, very performant. So OpenShift we talked about. This is a platform not just for developers, for developing applications, but also running those applications, okay? So developers develop containerized-based apps, and you can also push them through to production. Maybe the production apps run on a different type of infrastructure, right? Maybe it's running on solid state, whereas the development guys, maybe they develop on slower infrastructure. The key items to think of here is the source-to-image components. So just a little bit of a segue with the province of BC. When we did our hackathon, we actually invited some of the developers the second day to bring in source code that they'd actually written. and we showed them how to take that source code using source to image into a Docker container, and from there into OpenShift, okay? So it can run traditional workloads. So you can take that source code, do source to image, and fire up a container, and for the most part, that will work, okay? However, it's likely that the application is elastic, right? It doesn't know how to scale up and down, right? So there'll be some work required there. Or you can deploy native cloud apps right out of the gate with that elasticity built in, right? So we showed them how to tackle both of those scenarios. Key components for OpenShift, so Docker we've talked about. This is the Docker format, right? This goes back to my Open Container Initiative comment. This is the Docker format. This is not Docker the company, right? This is not Docker Swarm. This is the standard format that the industry is working with to be able to portable across the different public cloud stacks. And then for the orchestration piece, we're using Kubernetes. Okay, so Kubernetes came out of Google, and we are the top contributor to both of those, with the exception of Google and Docker, we're the second contributors to those open source projects, right? So we contribute thousands of commits to those projects, okay? So this is just a quick build out. So at the bottom, you've got the Red Hat Enterprise Linux and or Atomic Host. So within that, we have the runtime for Docker, right? So you can install Atomic Host and you get the Docker runtime built in there. On top of that, we have the Kubernetes components. So this is software-defined networking, storage, the registry, right? So do I want to store my images somewhere? Where do I store them? How do I access them? Logs and metrics and security. And above that, we have the additional secret sauce of presenting a developer's experience. So we've got an orchestrator, Kubernetes. We've got Docker, the format. But now how do I allow a developer to go through a CI/CD pipeline? What does that look like? What are the different stages of that pipeline? So that's the developer experience. And that also includes a service catalog. So again, we're thinking about reusing stuff, right? So if a developer's created something, I want to be able to reuse it. We can put those components into a services catalog. And then across the top, you have your different applications running in containers, okay? You can run a lot of different workloads in containers. Anybody who tells you you can run anything and everything in containers, that's not true, right? I'll also make the statement that, at least today, containers are not replacing virtual servers, okay? They are different constructs. One is an application virtualization, and one is a server virtualization, okay? So these two technologies will always coexist for a little while here. Now, does that mean to say that containers won't get to a point where they will be able to do everything that virtual servers do today? Possibly, okay? But anybody who tells you likewise, I want to put everything into containers, just like I want to put everything into the cloud, you could certainly do that, but there's certain workloads that don't make sense to push there. It is a polyglot platform. What do I mean by that? It supports a lot of stuff, okay? Any Windows people in the room here? .NET guys? Oh, wow, okay. Okay, for those that may be interested in this, we support .NET Core. So in other words, customers that are coding in .NET Core, they can take that .NET Core and push it into OpenShift. On the second one down there, you can see MS SQL, right? So, I was on a stage similar to this about 6 months into my tenure with Red Hat with my peer at Microsoft. And people couldn't understand why Red Hat and Microsoft were on the same stage. I mean, we're supposed to be mortal enemies. But we've done a lot of work. We've done a lot of really, really good work. And one area focused on is databases, elastic databases. So SQL Server 2017 is fully certified to run inside a container on OpenShift. Okay? In fact, was demonstrated at our summit conference this past summer. Okay? Now then, if I'm a betting man, I'm just wondering what type of workloads they're going to be going after. I mean, there's a large database company, we'll not mention their name, that Microsoft might want to go and try and garner some business from. So this gives them the avenue to run these workloads on a Linux platform and actually try and go after that business. Okay? So this is the sort of true build out. So we talked about that pipeline before. So OpenShift becomes your platform that allows you to orchestrate and run applications in containers. It allows you to run elastically workloads. It optionally allows you to put a persistent storage layer underneath that, so you can again have the complete end-to-end experience be agnostic from the public cloud stacks. And then if you need multi-tenancy, you need self-service, then you have optionally, again, the piece on the front there, which is Cloud Forms, okay? We talked about ROI. You can read those numbers. They are very compelling, extremely compelling, okay? And we'll provide copies of these slides afterwards, but we've proved these numbers out over and over again with different customers. Innovation labs we spoke about, okay? Hugely powerful. So a lot of customers we go into, they're less interested in greenfield applications, but they have a box over here in the corner that's 20 years old, that's got power and blinking lights, and it's got some critical application for their business, and they want to try and modernize that. They want to transform, right? And this is where Innovation Labs is hugely powerful, right? Where our team will come on site for a residency for a couple of 4-week sprints and help them create a minimum viable product in containers that performs and functions the same duties as that box in the corner, okay? Again, you're not alone with this, right? I mean, there's customers have been doing this for several years. Your public cloud providers have been doing this. This technology is now trickling down into the enterprise space. So we talked about, Todd sort of articulated some of the compelling reasons why they went with containerized applications, but here's just a summary of some of my key takeaways, right? And you may be able to relate to this in your business. So different project teams developing different applications, no code sharing, right? No purview over standard development tools, no frameworks, no security standards, okay? So you map this onto a large entity like a provincial government, it becomes a costly proposition, right? Every ministry is doing their own siloed development. There's no code sharing going on. So the takeaway from the province of BC is, they used OpenShift to reduce their ability to provide infrastructure for their developers from literally months to minutes. I always quote 12 minutes. I think, Mike, that's the number that you've quoted quite a bit, right? It's hugely impactful for the developers. They can go self-service, click, and have that infrastructure ready to go. They're able to authenticate through one framework, so in their case it was GitHub, that's the central repository for source code. They had elasticity, okay? So now their infrastructure does this, right? They're only paying for consumption of their infrastructure when the application requires it, okay? Code sharing. So the code that's developed as part of the projects that are running OpenShift is upstreamed. It's immediately open sourced. And we've already seen, I don't know if Todd's in the room, but we've already seen examples of one ministry grabbing source code from another ministry to actually accelerate their development activities, right? The federal government in Ottawa has already grabbed the DevExchange concept and source code to stand up a federal equivalent of the DevExchange, which is in beta right now. You can Google that, right? So this is huge, right? They're not developing in silos. Now, I live in the city of Port Moody, right? And I regularly meet with municipalities, right? I will not name them by name, but I meet with municipality A and I talk to them about mobile app development. They're developing this cool app that tells people when to put their garbage out and what type of garbage they're collecting and all the events going on in that city. And I'm like, well, have you spoke to City B over here? Because they're doing exactly the same thing. I met those guys last week. And the answer is, well, no, we're not, right? So code sharing is hugely powerful if it's done correctly, right? So it just accelerates that process. It pushes the cost down. And as a result of all of these key results, and this was a no-brainer for us, right, is the province was nominated and won Innovator of the Year for Red Hat this past summer for the open source way. We have 5 categories, and they won the open source way, okay? So what they're doing is, for a government, is revolutionary, right? For a government, it's just phenomenal. I mean, you don't expect governments to work like this, but what they're doing is transformational. Reference material will be in the slides. There's lots of videos out there of Peter and Todd in various interviews. So I'll hand over to Gerald, and I hope you enjoyed the demo.
I hope I enjoy it too. A little callback to Chris's talk about Ansible. Sometimes we tend to think of Ansible or automation tools as something for the operations folks, right? But I'm a developer, and I live and breathe by Ansible. When I joined Red Hat about 1.5 years ago, it would take me maybe a day, 2 days to get an environment like this provisioned, right? In AWS, all my demos installed, ready to go. Now I have everything Ansibleized in, that's the new term, by the way. I'm coining that, patent pending, Ansibleized. Don't use that, Chris. I've got that one. So, I've got all my demos and everything Ansible ready to go in Ansible. I can provision everything in an hour, right? Saves me a huge amount of time. About 2 hours ago, I was playing with my demo, and I realized, oops, I broke something. I had done this demo yesterday, and I decided to play around with it a bit to see how it would react in a new situation. I realized, oh, geez, I broke something completely. Instead of spending a lot of time figuring out what I broke, I just deleted it and recreated it with Ansible, and 10 minutes later, we're back, and hopefully this demo will work well today. So let's get on with the show. So what we have here is the OpenShift console. So if I'm a new developer, for example, I'll call myself Tom. I come to the company and I want to get an application that I've been assigned to work on up and running, right? And ready to go. So I can start playing with it and understand what's going on with it. So I'm going to log into the OpenShift environment. Whoops, fat-fingered. Nice. Come on, there we go. The Wi-Fi is a little slow. It's going to be interesting for the interactive demo. So when I get into OpenShift, I essentially start off with a blank slate, right, as a developer. At this point in time, I can create any kind of application I want, and I can, as Pinky in the Brain like to say, try to take over the world. In this case, though, I'll just create a simple application or a simple project to start. A project is really how you organize your applications within the OpenShift environment. It's where all the security exists for OpenShift. So as a developer, when I create a project, at the start, I'm the only one that has access to that project. But I can add other developers, QA folks, security, et cetera, operations folks to the project as needed to support working on this project. So once I create the project, then I get presented with a catalog of items and technologies that I'll be able to use in the project to actually create the application. So you can see here I've got all the different technologies, Java, JavaScript, .NET, et cetera, that OpenShift supports out of the box. But just because Red Hat provides all these technologies out of the box, this isn't what you're limited to. If you're using some different language, like in my spare time I use a language called D, which nobody has heard of, to work on an open source project, but I could add this to OpenShift if I wanted to, no problem at all, right? You can also add your own templates to make creating your applications quickly and easily. So in this case, I have a new template that I've added, type, called the product catalog. So I'm going to go ahead and add that to my project. You see when I can do that, there's a bunch of parameters that I've defined as part of that template, right? And the template in OpenShift is a simple YAML or JSON file, right? There's nothing funky or different about it. It's very straightforward to create. I've got the name of the application I'm going to create, some memory limits that I can set for this application, both for the PHP container and the MySQL container. But the most important parameter is where my source code is coming from, right? So it's coming from this repository in GitHub. So at this point, I'm going to create my application. Continue back to the main screen. And now my application is starting to build. Now, for me as a developer, this was the real kind of Keanu Reeves whoa moment, right? I can remember all the times when I show up at a client when I was a consultant, and I get the 5 pages of instructions on how to set up my development environment, right? How do I get this application actually up and running so that I can be effective and productive with it? Inevitably, that's a 2 or 3 day process that I would go through. And then once I get to that part over and done, the next part is going to the operations team and saying, hey, I need a VM or 2 VMs or 3 VMs to create a new test environment for the branch or feature that I'm working on behalf of the business, right? That could be anywhere from 4 to 8 weeks before that got set up. When I was a young developer, I used to have a lot of ego, and I'd think, oh, those crappy operations people, they don't know what they're doing. Get going. Then I sat with an operations guy, and I happened to see what his queue looked like of tickets. And it was pretty ridiculous, right? And you realize those guys, they're working hard, but they're spending a lot of their time doing this kind of grunt work that they don't necessarily need to be done, right? A platform like this automates that and makes it easy. So you saw how quickly that was. I've got my application up and running now, right? And it's a simple product catalog application. The important thing with this application is I just gave it my source code repository, and using the source to image technology in OpenShift, it brought that together and created a new Docker image for me and then deployed and ran it as a container. So now I've got my product catalog up and running. It's talking to a MySQL database. And as I mentioned, at no time did I have to go to an operations team and say, hey, I need a VM, or I need this, or I need that, right? I could do all that within in the environment, be self-provisioned, and be ready to go. So very easy, very effective, very efficient. But from an operations point of view, as we talked about this morning, it's not the Wild West. It's not like developers are all of a sudden going to be launching, applications up the wazoo, chewing up all the resources, the compute, network, storage resources that you're giving them, right? The operations team is still in control. They're setting quotas and limits on what I can do, right? So they don't lose that control, they maintain it, but they remove all the friction, the ticket frenzy that goes on typically between those two teams, right? And it allows them to concentrate on the things that add value to the business. The other kind of whoa moment for me is, as a developer, I'm a big believer that you want to find your errors as quickly as possible. And when I did development in the past, a lot of what I did was kind of in clustered environments, right? And typically what would happen is you'd only have two clustered environments, a pre-prod and a prod. You might hit pre-prod 4 months, 6 months after you started writing code. And then you start getting into cluster issues, right? So I always recommended people have their cluster as early as possible in a development integration environment. But it's a pain to set up. You need more VMs, more things to do. Then somebody did this for me in OpenShift. What? Wait, what happened, right? I pressed a button, and instead of one instance, now I've got two, right? I didn't have to go to an operations team and say, hey, I need a new VM. I didn't have to go to the network team and say, hey, I need a load balancer of the farm. That's all handled automatically by OpenShift. And from my perspective as a developer, this is really where the benefit of OpenShift comes in, right? Is removing all that friction that you typically encounter when you're doing and developing a new project, both from the operations side and the developer side. So we can click in here, and you can see the various pods that are running. These are the containers. And you can see information that OpenShift provides you about the containers, right? I can see details in terms of what the IP address that's assigned to it, it's running, what its state is, etc. I can see what environment variables have been assigned to it in terms of configuration. So in this case, I've got various environment variables telling this container how to connect to that MySQL database that I'm running. There's metrics that you can view about the container that's running. In this case, because it just started, it's not going to show me a lot of metrics at this point. There's no history, but you can see, for example, it's using 90 megabytes, right? And then there's logs, a terminal I can use to interact with that container if I want directly. Within OpenShift, we have different kind of artifacts or objects that are used to represent the application, right? So we just saw the pod, which is actually the running container instance. We also have something called a service object, which is this product catalog down here. This is how this application is represented internally within OpenShift. So if you're, for example, writing a service and you have another application that's running in OpenShift that wants to communicate with that service, how does this cover it? Because that application could be running anywhere in that OpenShift environment, right? This spans 5, 6, 10, 100 nodes. Where is it running? That service is the key to finding that, and it's all done through a mixed DNS. And then finally, we have the route. How do things outside OpenShift communicate with this application? And that's this route object that does it. So at this point in time of the demo, usually I would take this application and then I would show you kind of another environment where I got it set up, where it's got a development, a test environment, show you a continuous integration pipeline, and show how I can make a change in GitHub for the code and automatically kick off a continuous integration process in Jenkins that's integrated with OpenShift and watch it go through the different environments. But today we're going to do things a little different, and we're going to have a little fun instead. So I've got a game that we're going to play. This is the third time that I've done this game as a demo, and this is probably the biggest audience I've done it for. So I'm a little nervous. I'm hoping it's going to work okay. So from an architecture perspective, this game consists of multiple components running in the OpenShift environment. It's a balloon game. You essentially pop balloons, and we'll all be playing it on our phones. There's kind of 3 Node.js applications that are providing the user interface. There's the game client itself where you play the game. There's an administrative client where I'll control the game as the administrator. And there's a leaderboard where we'll get to see what everybody's scores look like. All of these front-end clients are communicating through Ajax with a game bus that's running on a technology called Vertex. I don't know if anybody here is familiar with Vertex. It's a Java framework, essentially taking the Node.js asynchronous reactive type programming and bringing it to the Java world. We also have a score service that's running down here that's using JBoss business rules management system, and it's deciding how those scores when you pop balloons are aggregated. What's the value of the balloon? And then finally, we have an achievement server. There's various achievements that you can get, like for popping 3 balloons in a row. That's also using a vertex. So if you bring out your phones, this is the URL you need to go to for the game. And you'll see something like that when you start. I know my little screen's a little hard to see, but it'll essentially ask you to play the game. You can press the button. So I'll leave it up for a few minutes to give everybody a chance to get in. Does anybody play Pokemon Go here? My wife, oh, a few people, okay. My wife's a huge fanatic of it, and of course I heard all about the fiasco in Chicago when they had the Pokemon Go Fest, where they had too many people show up and the whole system crashed. So I'm hoping, keep my fingers crossed, that we won't get into that today. Like I said, this is probably the largest audience I've tried this demo with. Is everybody in? Okay. So what I'm going to do is I can start the game up. I just got to get my super secret password out of GitHub. All right, so we'll start the game. So what color is the background of everybody's game? Is it blue? Yeah. So that represents the environment that you're connected to, right? So we're going to do a new deployment where I'm going to switch your screen, essentially. But you can see, if you look up from the game for a second, that I've got my blue game bus and my green game bus. If I look in OpenShift, you can see that it's sending 100% of the traffic to the blue node and 0% of the traffic to the green node, right? So what the pipeline is going to do is it's going to build the application, and it's going to deploy that into the not live environment. And then it's going to prompt me to actually switch the game over. Now, the benefit of a blue-green deployment, for people who aren't familiar with it, is it allows you to fail fast, right? And to recover fast, which is the important part of failing fast. So when you roll out a new deployment, and let's say when you do that rollout, you update all your existing infrastructure, you deploy new EAR files, you change all its configuration, and then you get it going, and all of a sudden you start getting complaints, things aren't working, and you got to roll it back. Well, in that kind of environment, typically what you're forced to do is roll back to a previous snapshot of the file system. That takes a lot of time. There's a certain amount of risk with it, right? What a blue-green deployment does is you run 2 sets of infrastructure, and you can simply swap the network traffic between the two quickly and easily in order to recover that in, I don't want to say 0 time, but in minutes instead of hours. So everybody doing well in the game? So let's check our leaderboard while we're waiting for it to build. Ooh, Pineapple Nose. So whoever Pineapple Nose is, he's the leader right now, and we have prizes for oh, I see a hand. We have prizes for the top 3. So Winter Death is second with 340, and Thunder Moose is bringing up third with 335 points. The really cool thing with this game is it's all event-driven. Every time you pop a balloon, it's sending a message to the game bus server, which is in turn communicating with the achievements and score servers to generate all this information that then gets presented in the leaderboard, right? So all of these messages and everything that you're generating with those balloons are being handled in real time in OpenShift in this game. Where's my computers? Okay, so we've done the deployment. Now I'm going to do the switch over. I'm going to log into Jenkins, which is integrated and running within OpenShift. And I'm going to approve the change. Okay. So now if I go back and look, you can see the green route is handling 100% of traffic. But let me guess, because I've done this demo before, I kind of know I'm not telepathic. Nobody's screen has actually changed from blue to green, right? It's still all blue everywhere. And the reason for that is that OpenShift is smart when I do this kind of thing. It's letting you guys drain your connections off of the blue environment, right? This game is written using a persistent connection technology called WebSockets, which means you have a connection to the server so it can send traffic back and forth all the time. So as long as you have that WebSocket connected, you're going to be on the blue environment. Now, if everybody could refresh their browser, it should switch you to the green environment. You shouldn't lose your score or anything at this point. Everybody back on green? Now, sometimes it might take a couple of refreshes to do it, but generally it's pretty solid. So that's an example, very visually of how you can do a blue-green deployment in OpenShift. So let's have a little fun with the game while it's going. Let's give you an opportunity to, actually just got to log in again here. Give you an opportunity to score a few more points. There's a feature in the game called the Golden Snitch. We'll make that worth 5 points because 50 is kind of ridiculous. Turn it on. So you should start seeing a face appear that you can pop, right? That face is Burr Sutter. He's our developer evangelist. He originally did this demo in 2016 at the Red Hat Summit. If you get a chance, I highly recommend checking out that demo on YouTube. It's a lot of fun. He had, I think, 6 to 8 people on the stage running this demo. Today it's just been me, but I'm glad to see it's been successful. Hopefully nobody's had too many problems. Let's see how our leaderboard's doing. Well, Pineapple Nose is way in the lead, 803. Geez, that guy's got fast thumbs. Or fingers, I don't know which, but that's impressive. So that kind of brings it to the end of the demo. Hopefully you found that interesting and somewhat enlightening. I like this game because it's really, from a visual perspective, highlights how you can do a blue-green deployment in OpenShift really easily. Because you think about what I would have to do from a physical or virtual perspective to get this working, right? I would have to have 2 sets of VMs, 2 sets of physicals set up, load balancers, network team, ops involved. Every time I wanted to do a deployment, it's a lot of work. I did this for a telco for a portal, blue-green, and believe me, we start the deployment at midnight, and I was praying to God that we'd be finished by 8 in the morning because it took so much effort and time, right? Whereas in OpenShift, it's a piece of cake. All right, so I'm going to call the game there because people's thumbs start getting sore, I find. So let's put the game over. Okay, thank you very much.